My talk is about OpenNebula networking. We are a bit behind the schedule, so I try to be quick. And a couple of hints about SDN and NFV integration, right? So the first couple of slides is a brief recap of what is networking about in OpenNebula. This is more or less the high-level overview of the networking model in OpenNebula. We have the data center network backbone, which is usually leaf-spine combination of switcher or routed networks. Usually, these switches or routers are not under control of OpenNebula. We use it or assume that that infrastructure is already in place, and the virtual networks are built on top of that. And in our experience, more of the deployments is this backbone network is usually just a few top of the rack switches. Underneath, we have the hypervisors, and we have virtual switches, a software switch, which is usually a Linux bridge or OpenV switch. Those switches are controlled by OpenNebula and are used to build the virtual networks for the VNs. So on top of that, we have a virtual network abstraction with the virtual drivers in OpenNebula and the virtual machines attached to that network. So there are specific SDN products which are usually integrated with other cloud management platforms. But in OpenNebula, we use what we call like a built-in SDN. So it's not a full, future, complete SDN, but it's our goal with the networking OpenNebula is to provide a central point to define, manage, consume virtual networks for VMs. So it's kind of SDN totally or specific for virtual machine networking. We have experience in the past using an SDN to control all these switches, but in our experience, the resultant solution is very difficult to handle, to manage, to debug, because you have a lot of flows. You have to create full mesh of tunnels or grid tunnels between OpenV switches, and keeping track of that kind of complexities, in our experience, not really needed to set up VLANs for VNs, right? So as for any SDN, we have like a northbound interface, which is the XMRPC API, the virtual network section of the API. We provide an abstraction for the virtual network, an abstraction to list addresses to VMs, and even we provide a kind of self-service for virtual network with the capability of reserving addresses or making address reservations on virtual network reservation from networks defined by the admins. And of course, we have a southbound interface in the SDN terminology. We have drivers to interact with the network elements, and as I said, those are not what the full future SDN have to implement specific BGP routing or reactive flows or rebalancing of flows and that kind of things, but it's what we need to set up virtual networks for VNs, right? So this is familiar to most of you. So how does a virtual network looks like? We have a logical set of attributes that is basically an address space. We have IPv4 addresses, IPv6, or just plain Ethernet addresses to define the network. And from the last release, for 12, I think, we have security groups, which are lets you define filtering rules for UVMs, for inbound and outbound traffic, based on TCP, UDP, and ICMP protocols, right? And apart from these logical attributes, we have some physical or configuration-specific attributes, which are basically the VLAN ID, the name of the bridge we are going to interface with to set up the virtual network. And also we have some contextualization information, the DNS that should be used with this network, the gateway in this network, and we have the context package using this information to configure the VMs from the guest, right? Okay, so in this picture, I try to depict all the components involved in the southbound interface. As I said, the idea is to interface with mainly the network element or network devices in the hypervisors, which currently is a Linux bridge or an Open vSwitch. These hypervisor bridges are configured to set up private VLANs for the VMs. We have a couple of them, like EV tables. We can use VLAN tagging. We can use VXLAN, and this works okay if you don't have to traverse level 3 networks. If you have to do that, you can use protocols like VXLAN to route the VLAN traffic across level 3 networks. We have Stefan tomorrow is going to give a talk about multicast routing for VXLAN in data centers, and so we are going to get more details in that talk if you are interested in. Or maybe you can have a virtual router or an NFV that routes the traffic from one of the racks to another if the network is connected to other things. So in principle, these infrastructure drivers are able to configure and control the network elements, like another SDN, right? What do we have right now in OpenNebula? We have like 2 or 3 important sets of drivers. One is those based for Linux bridging, which I think that probably works out of the box with most of the Linux distributions, because we just rely on the facilities provided by the kernel. We have the VLAN tagging, we have VXLANs, we have EV tables, and we have just plain flat networks for VMs. On top of that, built using IP table rules, we have security groups. This is, I would say, a future complete set of drivers. Then we have Open vSwitch. We have for Open vSwitch flat networking without VLANs, and just a VLAN driver which implements port tagging to isolate traffic for VLANs. These drivers does not include the support for security groups, because most of the filtering rules that we have to set up in IP tables, we don't have support for doing that for Open vSwitch. So our plans is waiting for Open vSwitch to expose all the filtering functionality that we can use for IP tables and to implement that. And then we have VMware distributed switch interface to set up VLANs in a flat or dynamic mode. Also, we are working in a kind of driver to interface with virtual routers. The idea is that from the virtual network definition, interface with the network function virtualization appliances that we may deploy in the network to configure them. So I think that some of the issues or features that we talked yesterday, or we've seen in talks today, like dynamic DNS or NATing or that kind of things, we want to provide like an interface from Sandstone, let's say, if you will, to the admins to set up DNS for the virtual networks, or NATing, or routing, and that kind of thing. So we wanted to provide a coherent way of doing those things rather than having custom appliances. So this is a matter of defining the interface we want and delivering the the drivers to do this configuration. As you know, the configuration of a virtual machine is made in a before the virtual machine is created, post, after the virtual machine is created and attached to the bridge, and clean right after the virtual machine has been delayed. So if some of you need to tune or to adapt the behavior of what is happening in terms of network configuration for your VMs, those 3 points are the right things to look for if you need to adjust your configuration to your setup, right? What about the guests? So one of the things that from the beginning we wanted in the design of OpenNebula is to require as less as possible and being able to accommodate any topology. So if you look to other cloud platforms and in terms of networking, they are so strong in terms of requirements because yes, you have more functionality in terms that DHCP is working out of the box, but it only works if you follow in a specific setup or topology or complain a restrictive set of requirements, right? So we wanted to let people architect their networks as they need and giving them the flexibility to put what they need. So how do we configure guests in OpenNebula? I'm talking about level 3, 4, 5. So currently we have what we call context, and it's just an CD-ROM image where you get the information from the network, apart from a lot of other things if you need it. We have the IP, gateway, DNS, or any networking configuration attribute. Those network configuration attributes are defined in the network, so the information just flows from the network definition to the guest. You need specific scripts or boot scripts or like the context packages we provide for Linux and Windows. And in the past, we made a strong effort to integrate those scripts with Cloud Init and other projects, but we didn't get the kind of feedback we expect. I mean, the community was not responsive or as responsive as we need to get the solution working with Cloud Init, for example. So we have the context packages, and I think we invested a lot of time in the couple of past releases. And right now it's just a matter of installing the package in your guest and network is configured. Okay, so another important thing is about the NFV management in OpenNebula. So as you probably know, network function virtualization is the approach is to virtualize some of the network functions you have in your network and moving from hardware appliances that are expensive and closed and put that in a virtual machine to provide the same functionalities. If that is for your virtual networks, just a simple installation of a Linux machine with the specific packages for routing or DNS or DHCP or whatever is needed. But if you are doing that for your network backbone, you need more things. So these are some of the things we wanted to or are looking for to integrate in OpenNebula, which will benefit not only the NFV community, I'm thinking about in a telco-grade NFVs, but also high-performance computing or other VMs that requires high performance. The idea is that if you want to put a virtual router and that in your backbone network, you need performance. You need to be sure that you can provide enough bandwidth to support your traffic. So this requires some features that not all of them are supported easily in OpenNebula. For example, support for queue pages. You can put a row attribute for that, but these kinds of virtual machines needs to define queue pages. Other important thing is Numa Scheduling. You want to co-allocate the processors with the Numa memory in the Numa node with the memory or the memory banks that are going to be used by the virtual machine. So the scheduler and the core needs to co-allocate where the virtual machine is going to run, in which core, and also where the memory is going to be allocated in order to be in the same node. But also, one of the nice things we've done, thanks to our friends from Sarah, is PCI pass-through. In the last release, you can use your GPUs directly from your VMs. And that's a nice feature, because if you use the PCI directly, you can have more performance. But also, apart from the GPU, you can attach high-performance networking cards. So that's also needed if you want to virtualize part of your core network and use OpenNebula for that. So those things is some of the features that we are looking into incorporating in the next releases of OpenNebula. This is needed if you are working with your backbone network, but as part of the virtual network, an NFV is also quite interesting. So we've seen some deployments today that they're using that for implementing floating APs or NATing or whatever. So we have virtual routing in OpenNebula, and the thing is that the appliance didn't catch up with some of the features that we were implementing in terms of networking in releases. So we have decided to remove the virtual router that we have been provided till now, and we are working in re-architecting the whole virtual routing feature in terms both of the appliance we are going to provide and the interface to that appliance, because we wanted a more coherent and integrated solution for virtual networking or virtual networks with the virtual router. Okay, one of the things that probably you are going to see more features in the next releases comes also because some of the institutions in OpenNebula are part of Beacon. We've seen brief introductions today. So we expect to have some development resources allocated to this area. One of the things we want to take care of is cross-site networking. In most of the use cases today, we've seen hybrid cloud deployments. So one of the most important drawback if you want to deploy in a hybrid setup is what you do with your networks. So usually what people do is a VPN with your local network, and that works to some extent, but in some situations you need a more flexible and also more integrated solution with your local network. So one of the things we can do, or we want to do, is evolve this virtual router appliance to being able to link networks from other clouds. This is kind of tricky if you are linking networks from Amazon or DigitalOcean or public cloud providers, because they usually do, let's say, very special things with the networking inside the public clouds. For example, in Amazon, they filter out any local IP that has not been defined through the Amazon interface, even though it's a local or IP address. So you need to do special things. But the idea is that the virtual router here in this VLAN creates a tunnel with a virtual network router in other VLAN. This probably can go through the internet. Right now we have a prototype using GridApp and IPsec to build a level 2 and a stretched level 2 network across Amazon and a local OpenNebula cloud. And the idea is to make easy the deployment of virtual machines in a hybrid cloud. So this virtual router here can be linked to any other clouds, and your networks will be extended to those clouds. How do we do that? So this is the other level of SDN that I wanted to talk to you today. So this can be done using just Linux bridging and Ethernet encapsulation over IP. That's in the latest kernels. But also we can have, to link those networks, we can have an OpenFlow capable bridge like OpenVSwitch. Using that allow us to rely on or use an SDN or to control those switches that are going to link your networks. What are the benefits? The benefits is that in those situations, for example, you want to optimize ARP traffic, because usually broadcasting in such a scenarios is a bad thing. So using an SDN can capture DHCP request or ARP request and program flows in the switches, so the switches knows where a virtual machine or a host has been started. If one of these switches goes down, the SDN rebalance the flows and so on. We've been playing with ONOS, which is, I would say, a kind of lightweight SDN controller, and we have prototype implementations of this. So to end my presentation, this will be the OpenNebula network model view, considering all of these things. As we have what we call a two-level SDN, one which is the built-in SDN from OpenNebula to handle the switches, and we can have an SDN for OpenFlow capable switches to interconnect virtual network segments across clouds. So more or less, this is what we have, and these new things here, and the virtual router is the new features that we want to implement in the next releases of OpenNebula. Okay, so this is pretty much what I have for you today, and if you have any questions now, I don't know if we have time because we have behind the schedule, but in the coffee breaks or this night or whenever will be happy to discuss with you any of these things or anything. So thank you.
Okay. If there's any quick question we can do before the next talk?
It's all looking very interesting. How is HA? Is that something you've thought into that solution, how to set up routers as an HA solution?
In terms of networking, yeah, not really, but depends on the level. As I said, probably here, these are proprietary networks, includes HA, and these are these links here are, or switches are usually in fault tolerance configuration somehow, right? What happens if the idea with the use of an SDN, if you are linking networks, is that the SDN can rebalance things and tolerate and handle failures in that situation. So I will say that if we start using virtual routers to link your network across clouds, you will need or you can rely on the SDN to rebalance flows and find an alternative paths if some of the links fall down. That was the original idea.
The virtual So the virtual routers are also becoming the network controllers?
No. Well, the idea is the real idea. This is something that it's open to discussion. Is to let's use that. Add this component here to provide additional features to the network and the ability to this router to link to other segments. In that, okay, yes. In that case, this is part of the control plane somehow of the network. But how is this VLAN provided? Is as in current release of OpenNebula. This is an VXLAN, for example. The nice thing of this is that you can have here VXLAN, here you can have VLAN tagging isolated in another way, and you don't need to translate the IDs from one side to another. That is usually if you go to another SDNs, they need this kind of mapping. What is happening here, the traffic is they de-encapsulated here from VXLAN, for example, encapsulated here the Ethernet over IP, and re-encapsulated here with another encapsulation protocol. Oh.
Okay, thanks.
Thank you.